Okay, hello, grade 8. We're going to talk about metals because that is the name of the unit. So I figure it's time to start actually talking about them specifically. This is everything an 8th grader needs to know about metals, and you need to make sure to take notes. Go ahead and pause the video, grab yourself a piece of paper and a pencil, and be prepared to take some amazing, beautiful notes. And at the end of class, you will take a picture of your notes and upload them to the Google Classroom assignment. So let's first go over the basics. What is an element and what is not an element? We have elements. They are the most basic substances. They cannot be broken down into anything simpler. And they are made of only one kind of atom. We see elements on the periodic table of elements. All right, we have hydrogen, helium, lithium, gold, silver, those things. Those are all elements, and they're made of only one thing. Gold is only made of gold. Helium is only made of helium. All right. Then we have molecules, and those are more than one atom bonded together. All right, we have an example, O2. That's a molecule because it has two atoms stuck together. Two oxygen atoms. Also something like lithium hydroxide that you see down here. That is a molecule. We have lithium, oxygen, and hydrogen all stuck together and bonded into one molecule. Right? And last, we have compounds. And compounds are like molecules, but they're different elements that are bonded. For example, lithium hydroxide is also a compound. So something can be a compound and a molecule. That's possible. All right. Actually, all compounds are molecules, but some molecules are not compounds. So O2, that's a molecule, but it's not a compound because it's only made of oxygen. But lithium hydroxide is a compound because it's made of several things. All right, so those are just basic words you need to know. Let's go to the next slide. What are metals? So metals, they are solid at room temperature with the exception of mercury. Mercury is a liquid at room temperature. And fun fact, actually hydrogen, it's in the metal section of the periodic table. And we say it's a gas because naturally it's a gas. But if you were to take it and make it super, super, super cold and freeze it, it actually does turn into a metal. All right. But we typically don't say hydrogen is a metal because that's not how you find it. All right. So metals are usually shiny, especially if you scratch off the corroded layer. You're going to see shiny, as in you can see light bouncing off of it, or even see a reflection of yourself in it. All right. They have a high melting point. They're good conductors of heat. That's why we have metal pans in our kitchens. They're good conductors of electricity, which is one of the quickest ways to find out, is it a metal? You can see if it completes a circuit. If the light bulb comes on, then it's probably a metal. All right. And they are malleable, which means when I hit them, they smash into sheets. All right. You could also say malleable means that they can be mushed. They're mushy. All right. I can press down on them and they don't break into little bitty pieces. All right. They can be smashed and mushed. They're ductile, which means when I pull them, they're going to stretch into like a wire. Right? But if I think about like glass, right? Glass is not a metal. When I hit it with a hammer, it breaks into little pieces. When I try to stretch it, it would just break. So glass is not a metal because it's not ductile and it's not malleable and it doesn't conduct electricity. They're high density, meaning that for a small amount, they're going to have a lot of mass. There are exceptions. Lithium does not have a very high density. Potassium, sodium, those will all float on water. All right. Most all of them are going to be corrosive, meaning that, or they corrode, meaning that if you expose them to things like water or oxygen, they're going to combine with those elements and turn into something else. So like iron, it rusts, it turns into iron oxide. And if they're in a reaction, they are going to be losing electrons most of the time. We know that, for example, with lithium combines with chlorine, right? It has that one electron on its outer shell, so it's losing that electron. And that's, they're on the left side of the periodic table. That's what happens. Now, to also understand what a metal is, we want to understand what a nonmetal and a metalloid are, all right? So nonmetals, things that are not metals. We can see there, elements that are not metals. All right, they have low elasticity, meaning they're not elastic. They don't stretch and then go back to the original shape. If I take a piece of metal, like let's say iron, and I stretch it because I'm really strong, and when I let go of it, it stays in that same shape. It doesn't go back like a rubber band would. Okay. Nonmetals are insulators of heat, so the heat cannot travel through them. They're insulators of electricity. Living things are almost always made of nonmetals. Yes, you do have metals in your body, but most of your body is not made of metals. Some nonmetals can be solids, like carbon, phosphorus, sulfur, selenium, iodine. But most nonmetals are gases when found in nature, and you can see those lists there. You don't have to copy this every single one on there, but it'd be nice if you did draw that little diagram onto your notes. And like I said, feel free to pause. So you have a periodic table in your science folder, or one you brought home because I printed it for you, or in your science guide. If you don't have one, well, it says here, make a copy at the copy machine. Maybe you could print one at home and do what I said, all right? But the task is you're going to color in the elements that are nonmetals with a color, and you're going to color in the metals with a different color. Now, if you go to a lot of periodic tables, this is already done for you. You can quickly see this. And we need to have a key at the bottom showing that the metals are this color and the nonmetals are this other color. All right. All right. And I went ahead and added a periodic table for you. We're only coloring in these non-metals here. So choose a color. Obviously, don't color it in black. It will destroy your periodic table. And we're going to color in these non-metals. So you can see there's this kind of line right here, carbon, all the way down here to whatever Rn is. Those are the non-metals. We're just coloring that in with a color of your choice and then labeling at the bottom that, for example, in this one, yellow equals non-metals. All right. So pause this, and when you're done, come back, unpause it, and let's go to the next slide. So those are the non-metals. So next up, we're going to talk about the metalloids. The metalloids, they look like metals. If you were to look at them, you find the rock of it, you're going to say, that's a metal. Why? Well, because they're gray or shiny and things like that. However, metalloids are not malleable. So if you find something and you want to find out, is a metalloid or a metal, you hit it with a hammer. If it breaks into little pieces, like glass almost, that's going to tell you it's probably a metalloid. All right. If it smashes and flattens out, then that's going to be a metal. Metalloids are poor conductors of electricity and heat. And I say poor meaning they are semiconductors. So they do conduct, but really, really bad. Not enough to light a light bulb, probably, with a regular battery. And they can be mixed with metals to form alloys. All right. So here's some metalloids right here. Boron, silicon. You can see silicon is super shiny. It really looks like a metal, but hit it with a hammer and it will break. Germanium, tellurium, antimony, and arsenic. So these are some metalloids. And you can see they're gray, they're shiny, they look like metals. So next, we're going to color in the metalloids with a new color. Don't color with a pen. You want to be able to see what's behind it. Now, I guess if you have a highlighter, that's okay, so that we can see where are the metalloids. And if I go back here, we can see here's the metalloids. They are red. These red ones right here. All right, so color those in and label them on your periodic table, metalloids. And pause if you need more time, because now we're moving on to types of metals. So in the metal section, there are different kinds, and they have different properties, and they're in different places of the periodic table. So we're going to go through these, and you should probably copy this down into your notes. These are the types of metals. So transition metals. These are the metals that when you think of a metal and you list one out, it probably is going to be one of the ones you list out, the most common ones. And the reason why we know them the most is because they're strong, they don't react, they don't explode when they get wet. They're the kinds of ones that we use to build things, jewelry, houses, cars, things like that. And transition metals are in the center of the periodic table. I'll show you a picture in a little bit. They're hard and strong. They're good conductors of heat and electricity. They have a high density. They're less reactive. And they have high melting points. And because of all these things, they're super useful. All right, we don't want to build a bicycle out of potassium because then it would explode when it got wet outside and also not be very strong. All right. So we can see the coloring for the transition metals. Choose another color. And you can see right here, it starts with scantium and goes down here to zinc and all the way down here to 109. All right, so color those in. And as you're coloring, maybe you can see if you can remember what some of these are. You should know what AU is by now. PT probably. HG maybe. All right, fill those in and pause the video if you need to. Next group is the post-transition metals or the poor metals. These metals are metals, but they're very wimpy. All right, so we have things like lead. It feels like it's plastic. Aluminum, it's super, super light. Gallium will melt in your hand. Yes, you can buy it on Amazon. And I think the school has some, so remind me to show you. They're all useful because of those properties, though. And they're not very reactive. So a lot of times we use these metals to cover up a strong metal and protect them, right? Because they're not so reactive. So we can put the strong metal in the middle and then cover it with something like aluminum, which is less reactive, and it will protect the metal that's inside. So you have a little, the best of both. And here we go. The poor metals, they're weak, low melting point, not reactive. And here was our list right here. Tin is very often used to cover certain metals to protect what's inside. You can cover the iron with tin, and that way the iron doesn't rust because the tin doesn't react so much. So color those in with another color. Pause the video if needed, and let's move on. Now we have the alkaline metals, which you probably know very well because we've talked about them quite a bit. These are group 1. Everything in group 1 is an alkaline metal. And if you've had a little bit of time messing around with them, you see that they are very malleable. They're very easily cut. I can take sodium and cut it with a knife. All right? I can cut it with scissors. They produce a base when they react with water. So when I put them into water, they're going to react violently, possibly cause a fire, maybe explode, and then that water will be basic. They also react quickly with the air. So if I take a piece of sodium, lithium, potassium, and I cut it, it's going to be a super shiny, beautiful metal. But within seconds, I'm going to see it turning into a different kind of color, like either a white or a dark gray, or potassium. I believe it's like a purplish kind of gray. All right, and as you go down the group, they get more reactive. All right. So feel free to use the internet and learn about the other groups that we didn't mention. Fill out a graphic organizer. How about just write one fact about each of those groups that were not mentioned? That would be the rare earth elements and the alkaline earth metals. All right. And go ahead and color in and label those as well. All right. So one fact, you don't need a graphic organizer. And you have now reached the end of this presentation. You have all of this information in your notes, possibly in your folder. Feel free to go back in the video to fill in all of your notes. All right, guys. Take a picture of all your notes. Make sure I see it on the Google Classroom assignment. That way I can see that you are working instead of playing video games and looking at TikTok. I miss seeing all you guys. I hope we can see each other soon. It's looking more and more like it'll be February, but see you next class. Bye-bye.